Hi, and welcome to reInvent. My name is Carl Meadows, and I want to welcome you to the security overview for our Amazon Elasticsearch service. Today, we're going to do a deep dive into the security settings in Amazon Elasticsearch service and how you can use it to host even your most sensitive data as well as your compliant workloads, all safely with your teams working together in a very seamless fashion. As I mentioned, my name is Carl Meadows. I have been with Amazon Elasticsearch Service for over 5 years. I joined just before launch, and I'm really excited to be here today talking to you about security, which is something that's very near and dear to our customers' hearts, and which we treat as always job one when we're launching a product and delivering features for our customers. It's important as we look at, before we go into what the Amazon Elasticsearch service offers as it relates to security, is to understand how open source Elasticsearch, what it has for security. And the answer is nothing. There is no security layer for open source Elasticsearch service, or for open source Elasticsearch. It is just an API, and there's no authentication or authorization. So anyone who can hit that API has full access to that cluster. So what that means in practice is that customers that want to secure Elasticsearch typically put a proxy in front of it. And they use that proxy to authenticate users before they can access Elasticsearch. But even when that's set up properly, there's no way to do any sort of differential access, which is very granular access down to who can access which indexes or what documents or what fields. This clearly doesn't meet the audit and security compliance standards that most enterprises have. Not to mention the authorization and authentication issues. There's very little ability for the proxy to provide any sort of audit log as to who has accessed what data as well, because all it would be able to log is actual URL strings. So you wouldn't actually be able to see if there was a security incident, what data was accessed by who, or anything that had happened to it, which are fundamental pillars of a well-secured system. So today, as we jump into this, I do want to set the stage. We're talking about Amazon Elasticsearch service, which is a fully managed service for open source Elasticsearch. But what that means is that AWS has actually built a service that allows you to very easily deploy, manage, and the subject today, most importantly, secure that Elasticsearch environment so that you can focus on using Elasticsearch and getting all the great benefits out of it and not have to worry about scaling or securing and setting up these proxies, and how do you do this in a secure way. Some of the features that we're talking about in this security are actually part of an additional open source project that AWS has sponsored that's called Open Distro for Elasticsearch. And what this is, Open Distro is a set of extensions to Elasticsearch that are all also open source, that are Apache 2.0 licensed, that extend Elasticsearch to add a lot of these security capabilities we're going to be talking about today. And this is available for anyone to use anywhere, not just on the service. So Open Distro for Elasticsearch is a very key part of how we provide a secure Elasticsearch service, and we've open sourced it as well for others to use. Also want to just touch briefly on what is Elasticsearch used for, and the answer is a lot. Elasticsearch is a really powerful Swiss Army knife. It's got a lot of great capabilities. But if I'm to boil it down to the two biggest buckets, it would be full text search. It's a search engine. It's a super powerful search engine. If you want to embed search into your applications and you want to provide great customer experiences where you can get highly relevant and performant search results in your application, Elasticsearch is the go-to tool for that. On the flip side, because of all of that flexibility and its ability to aggregate and find relevant data, it's become exceedingly popular as an observability tool for log analytics. And this is where you take large volumes of machine-generated data, you stream it into Elasticsearch, and then you can provide real-time access to identify issues with your infrastructure, your applications, for security analysis. This could be logs, it can be metrics, it can be traces, and Elasticsearch is just a great tool for that too. So in that use case, it's typically often used by engineers and development teams as part of their tool set to make sure that they can provide an excellent quality of service to their customers. So first, let's start with a high-level overview of security in Amazon Elasticsearch Service, and it's really broken into 4 pillars if we try to break it out in a way that's easy to categorize. The first is access. So who can actually access the endpoint at all? Is it secured by network or the data? Is it encrypted at rest? Is all that data in flight encrypted? So making sure that you've got good physical security and network security access. Then is authentication. So how do you authenticate the users that are accessing the endpoint are who they say they are and are the users that you want to let into that endpoint. The third is authorization. So once you've authenticated those users or who they say they are, do you want to authorize them to access what data, what documents, what fields? And the last is you've got to be able to audit. So anything that those users have accessed or authorized, you want to be able to capture what they've done for security purposes and compliance purposes. And then let's just very high level, let's talk about like what is Elasticsearch in case that, how it fundamentally works. So Elasticsearch is taking in JSON documents, which are, semi-structured documents. They could be coming from being generated by machines such as logs from applications, from servers, or be documents that you're putting into a search engine. Those are being put into Elasticsearch and they become instantly indexed and become searchable so that the search engine can very quickly find data from across huge volumes of data generated in real time. And then your users, be it applications, analysts, or a search application or analysts and your engineers can then access that data either via an API or via the Kibana visualization tool, which we also provide as part of the service, which provides a visualization tool for you to build dashboards and to inspect and browse your data. Here's an example of sort of what a Kibana dashboard would look like. I've got all of this data coming in. I can quickly build bar charts, heat maps, line graphs, all the types of things you would use to help you really visualize and understand the health of your applications and what's going on in your environment. Okay, so now we're in security. Let's dig into all of the various security features that we have on Amazon Elasticsearch Service. The first point that you'll want to think about is, where is that endpoint? Is the endpoint only, the REST and Kibana endpoint only accessible to a VPC inside your environment? Or is it a public endpoint that can be hit externally? Both of which are okay. You can secure a public endpoint. We'll talk about being able to secure public endpoints. But a lot of customers for production environments or anything sensitive want to make sure that their endpoints are also secured inside a VPC and don't have any external access without getting access first to that VPC. Then we provide CloudTrail logging for any sort of operation performed by Elasticsearch. So that's essential. Pretty much all AWS managed services have CloudTrail built into them. We provide encryption in flight and allow you to specify a minimum TLS version. So that ensures that the traffic that's in between nodes or in between clients is always secured and it can't be intercepted by any sort of man-in-the-middle type of attack. We also ensure that we provide an option to allow you to do encryption at rest and use your own KMS keys. And this ensures that the data on the disks is actually encrypted as well so that no one can get direct access to the data that way. We are part of all of the major AWS compliance programs. So if you've got workloads that need to be PCI compliant or HIPAA, or you want to look at our SOX audits, all of those programs are available and for you to use so you can be confident that you can fold Elasticsearch into any opportunity or use case where those compliance programs come into play. And you can also use IAM to authenticate directly to that endpoint. So it does have a direct integration with IAM, which is Identity and Access Management, Amazon Identity and Access Management, so that you could sign requests with those IAM principals directly to ensure that only those IAM users and IAM principals can access that data and the right data. Now, the features here in orange are ones that we've launched just this year. So we're always building on security. So we've added, authentication into Kibana. We had authentication in Kibana using Amazon Cognito, which could be, you would allow your users to use usernames and passwords from their own systems to get into Amazon Elasticsearch service. But we've added SAML and SAML support, which will allow you to much easier access to be able to directly leverage like Active Directory FS or Okta to then allow your users to use those names and passwords. That's actually the demo. We're going to go over a quick demo and walk through the SAML integration because it's a really important thing, and it'll make it way easier for our customers to really leverage all of those security capabilities we're talking about today. We also added a basic auth feature, which is just a simple username and password. This can be really valuable if you just want to set up something very quickly, but you do want to secure it. And the simplest way to secure it is put a username and password on it. Like I said, it's kind of surprising that Elasticsearch open source just doesn't have that simple capability. But it makes it a lot easier if you're just spinning up a demo and test and you don't have access to the IDP or need access to SAML. You just want to get something set up and you want to know that it's secure. We also added fine-grained access control feature earlier this year. And that feature allows you to do access control down to the index, particular cluster operations, be it who can delete documents, delete indexes, perform snapshots, and down to the field and document level access control. That feature also added Kibana multitenancy, which allows you to have different sets of workspaces for users to interact with the cluster. We'll also include that in the demo. We'll show a demo with multitenancy and how that works. We recently added a feature called with the friendly domain name, which this makes it much more convenient if you can set up a domain and you can have an endpoint associated with it, like mykibana.company.com, and then map that back to the service provided endpoint. And so all of your clients and your users can use that friendly endpoint, and you can swap the clusters out without having to update all your clients. So this was a really important feature. I'm really excited that we recently launched that. And then, as I mentioned earlier, we also added rich audit logging at the Elasticsearch level. So that you can define very granular policies, like down to anyone that accesses these very sensitive documents. I want to capture a log of it. I want to capture a log of who accessed this document. I want to capture a log of anyone who mutated an index that might have sensitive information in it. You can set all of those policies now in Amazon Elasticsearch Service. So now let's make this real. Let's look a little bit at what the actual architecture is when you get an Amazon Elasticsearch Service domain. First of all, each domain is single tenant. It's a set of instances that are dedicated to your domain, and they're in their own dedicated VPC. So there's no other customers in it. There's no other access to that domain except for the load balancer who provides that endpoint. And they can provide that endpoint into your VPC or out into the public. That endpoint is then backed by data nodes and leader nodes. And also we have a special ultra warm nodes, which are our nodes that allow you to scale that data out into S3 and really drive down your cost. Other interactions are, metrics are pushed out into CloudWatch, logs are pushed out into CloudTrail, or the control plane logs are pushed out into CloudTrail. The actual Elasticsearch logs are pushed out into CloudWatch logs. You have various pipelines you can use, such as Kinesis Firehose or AWS DMS, Database Migration Service, or even CloudWatch logs to populate data inside your domain. Okay, let's dig in a little bit into what are some of the core concepts of security when we look at the fine-grained access control features inside Amazon Elasticsearch Service. And we're going to go into some of this in the demo as well. So when it comes to authorization and authentication inside Amazon Elasticsearch Service, there are a few different principles that make that up. First is the users. These are the folks that authenticate into the cluster and what permissions that they have. Then the permissions are the sets of things that they can do. Those permissions are grouped into roles. A role can include sets of permissions as well as what tenants, which we'll talk about in multi-tenancy, that those users can access. So what dashboards they can see, what visualizations they can see, what indexes they can access, or documents and fields they can access. You also you don't actually have to just use users. You can use what's called a backend role, and a backend role is really just an entitlement. It can be a group, and so then I can leverage those groups to then map to roles, and we're going to talk about this in the demo as well. So I map those users and backend roles to roles, and then with the joining of those two things, we get what access that customer has and what their user experience is when they interact with the Elasticsearch environment. And I mentioned multi-tenancy is a very powerful part of that, because multi-tenancy is then how you group these permissions together and have basically spaces where the different teams can operate, where they don't see each other's dashboards, they don't see each other's visualizations, or even their indexes if they're not given permission to. So we'll walk through the authentication flow just so you have an idea of how this actually works. So there's multi-layered authentication here. Whether or not your data is coming in, your calls are coming in through a Kibana interface or directly to the API. The Kibana interface is going to authenticate either through SAML Auth, like we talked about, and we're going to demo, or using Cognito Auth, which is another AWS service. And that's going to provide them with, you identify the users and the roles that, the backend roles that are associated with that user. Or you can use IEM directly to authenticate as well, or that username and password. Then there's two layers of policy before you even get to the domain. The first layer is this edge policy, and this is the resource policy that before you get to Elasticsearch, it's going to inspect it. So for public endpoints, this can be IP ranges. It can be what the IAM principals are that are accessing the endpoint. You could also consider that the security groups for VPC access could be sort of considered as part of an edge policy, because if the traffic isn't coming from something that's authorized in that security group, it'll just be rejected before it even hits Elasticsearch. So this is the edge policy. And then you have the actual security policy in the engine, which is where a lot of what we're going to be talking about today. And it's going to be powered by that open distro for Elasticsearch security plugin, which we're going to show, which is going to identify the user, whether or not they're authenticated, whether or not they're authorized, any backend roles they have, and then it's going to apply those roles and those role mappings to only give them access to what they're allowed to have access to, or deny access. So now let's talk one more slide about, I mentioned VPC and how this interacts with VPC, but it's worth maybe going into just a little bit more detail here. So in a VPC environment, which is what we recommend for most production environments, is you'll have your endpoints or your Kibana. They're going to be granted access to the endpoint in your VPC by having access to the security group where that endpoint resides. So when you set up Amazon Elasticsearch Service in a VPC, it's going to ask you for some sitter ranges, which are IP ranges, that have access to security groups, that only traffic coming from that security group is allowed into that VPC, and then allowed into the Elasticsearch Service domain from there. Once it gets past that boundary, like I said, then there's IAM authentication and the security plugin authentication authorization, and then you get access into the domain. So there's multiple layers of security with the service. And I mentioned multi-tenancy a few times, so this is just a quick overview of how multi-tenancy works. So with Kibana multi-tenancy, teams are able to share a cluster, but they only see the data and the dashboards that you give them access to and the tenant that they're a part of. So you basically have a group that's in a role that has a set of permissions and a set of indexes that they're allowed to see, and they can all be using the same cluster. You can have, many teams using the same cluster, but to each of them, it looks like their own cluster. With only their data, they can't see anybody else's dashboards, anybody else's visualizations. And that allows you to get a lot of efficiency because you can have lots of teams sharing like a larger cluster that might be more cost efficient and operationally easier for you to support. Without them interacting with each other at all or having any data exposure across them. So the tenancy feature is really powerful, and it works with the access control. One other feature I want to dig into a little bit is this friendly domain name feature. I'm a real big fan of this. It makes it a lot easier for users. So with this feature, it integrates with Amazon Route 53 as well as Amazon Certificate Manager to allow you to set up a friendly domain name. And then that domain name you can use with all of your clients, and your users can bookmark it for their Kibana access. But then you can rotate clusters out behind it. So you can the individual Amazon Elasticsearch service domain could be removed and replaced, and it doesn't disrupt your clients at all. And this just makes it a lot easier operationally and for your users. And this also integrates with the SAML support that we're going to demo, which the two together is a really nice combination. And with that, I want to go ahead and jump in. Let's see how all this works. So let's go ahead and jump into the demo. Now let's see how all of this works together in action. For this demo, I'm going to walk you through how you can use SAML to connect your Amazon Elasticsearch service domain with your existing identity system. This will allow your end users to connect to Kibana using their same usernames and passwords that they do for other corporate apps. And you can use the groups and entitlements that they have in that identity system to further refine their access in Amazon Elasticsearch Service as needed. So here we are in the Amazon Elasticsearch Service console, and you can see I have a domain set up called SAML test. Let's take a look at this domain. So this domain is configured with a public endpoint, and it's running Elasticsearch 7.8. You can see I have not yet configured one of those friendly endpoints I talked about earlier, which are really nice. I'm using the system-generated endpoint, but both would work in this scenario. And this domain also has been configured with fine-grained access control is enabled, which is required for SAML, and as well as SAML. And you can see here, if we look at the SAML details, this is the information that I would need to also configure on my identity provider in order for them to be able to interact. And you can see in this case, the identity provider from this string is actually Okta. Other things configured in this domain is we've also got HTTPS is required, encryption at rest is enabled, and node-to-node encryption is also enabled on this domain. If we take a look at that edge policy I spoke about earlier, we can see that the edge policy actually is open. And this is because we've got the access control, authorization and authentication are being done by the fine-grained access control. So therefore, I don't actually need to configure anything on the edge policy if it's not necessary. Okay, so from here we have our domain. SAML is configured. Now let's jump over to Okta. So here I have my Okta console. In Okta, I actually have an application set up. That application here you can see is custom SAML Amazon AES or Amazon Elasticsearch Service. And if I click on that and then look at General, I can see these strings here and these settings also correspond with the settings that we configured on the Amazon Elasticsearch service domain. So these refer back to that are allowed communication between the two systems. Also, in Okta, I can look at the assignments. And so these are, in this application, these are the users and groups and entitlements that are allowed to access that application through Okta. In this case, I've got a few users set up. I've got SAML admin, which we'll use to configure the cluster. And then I've got two users who are myself and a product manager on my team, Jamesh. If you look at my user, this is me, we can also see that from Okta, I belong to a group called Amazon ESPM. We'll need to remember that because we're going to show how we're just going to use that group to give me access. We're not going to refer to me at all when we get sent down inside Amazon Elasticsearch service. So therefore, you can just use a group, and that group can control access. You don't have to manage permissions at an individual basis, which would be, can be very painful. Okay, so now we go back to the Amazon Elasticsearch service console, and we're going to go ahead and open up our Kibana endpoint. And let's go ahead and log in as the SAML admin. This is a user we pre-configured to have administrative access on this domain. And notice it redirected us to Okta, the Kibana. And so now Okta authenticated us, and we're in our Kibana dashboard for that domain. And if we go and look at the Discover tab, where you can look at your index patterns and look at the messages directly, you'll see that I've already configured 3 different sample data data sets here. There's the e-commerce data set, the flights data set, and the logs data set. Each one of these is a separate index with a separate set of dashboards. So you can see these log entries here. And then if I go to the dashboards, you can see that I've got all 3 sets of those dashboards here. And those dashboards are fully populated with data. But what I want to do as the administrator is I want to delegate to the product management team just a subset of this data, just those Apache logs, that log use case data. So to do that, I'm going to go down into the security plugin. Now, this security is powered by OpenDistro for Elasticsearch security plugin, and it's what gets enabled when you enable fine-grained access control on your Amazon Elasticsearch service domain. And you'll see that there's some of the principles we talked about earlier, such as roles, role mappings, tenants. Let's look at the roles. So as we discussed earlier, the roles are sets of permissions that that can be delegated to different groups and users. In this case, there's some default ones, such as all access, which gives you full access to any cluster permissions, all of the indexes, fields, and documents, and any tenant that's on this domain. There's also a read-only role, which is really useful if you have users and groups where you only want them to see dashboards, you don't want them to be able to edit dashboards. You can just give them the Kibana read-only role. In this case, I want to give my product managers more than that, right? I do want my product managers to have full access to all the cool features like alerting and anomaly detection and SQL, but only on a subset of the data. So I've created this product manager role, and it's got a set of permissions, including Kibana read and write, which will allow them to create and manage their own dashboards, but only under the Kibana sample data log, which is just one of those 3 indexes that we looked at earlier, and in a separate tenant called product management, where anyone with this product manager role will be able to share dashboards and visualizations, but they won't be able to see others. So now that I've got this role, who do I want to give it to? Well, to see that, I go back to the role mappings. And on the role mappings, you can see there's the all access role is mapped to the SAML admin, which is how we got here and had full access. And I've got some contractors that have the Kibana read-only role. But the product manager role is not given to any individual users. It's given to this Amazon ESPM backend role, which that is, like we talked about earlier, that's actually a group from the entitlement, or an entitlement from the identity system through SAML. So if we looked back at Okta, we remembered, Carl Meadows had this group, Amazon ESPN. So that by assigning that backend role, anyone who logs into Kibana that has that entitlement will get the product manager role and will only be able to see those assets we just talked about. So let's see this in action. I'm going to go ahead and log out. And now let's log in as me. I logged in with my username and password. And look, it takes us back to this Kibana dashboard. It looks the same as the previous one, except for this time, when we go into Discover, and I still, this user still has all the full features like we talked about. But if I go into the Discover tab, we're going to see just the Kibana sample logs use case here. Let's go ahead and expand this range out a little bit. And you can see there's data here. And if we go into the dashboards, we're going to see, we didn't see the other dashboards we saw. We actually just see the product manager logs dashboards, which is the dashboard that they use for this log data. And they've tweaked it a little bit for their own needs, but it's their dashboard. And they don't see any other team's dashboards. So I think that demo shows us how we can use SAML and allow you to leverage your existing usernames and passwords and entitlements to grant and revoke access inside Amazon Elasticsearch service. Now, the demo I gave you was just obviously a very simple one with just like one group and some sample data. But you can see how you could use how powerful this feature could be if you have hundreds of groups and teams that are using Elasticsearch service. You no longer have to map those back into any other permission systems. You can just leverage the permissions you already have, use groups to delegate access, allow them to only see the data they need to have access to, and still get all of the benefits of Kibana, still be able to use all of those cool features, but and share cluster resources, but only see the data that they need to see. So I hope you enjoyed this demo, and I am we'll go ahead and wrap this part up. Okay, thank you very much. Okay, and with that, I'd like to wrap up our session here today. I hope that you found this very interesting. You learned something about how to secure Amazon Elasticsearch service and some of the features that we have available for you, and that that the reInvent is, even in this crazy virtual world, that we're able to get together like this, and you can, we can share experiences here at reInvent. So with that, I'd like to thank you.